So let's come to queue. So look, the queue, the meaning of queue in data structure is same as the meaning of queue in a literal way. So literally, what does a queue mean? In your daily life, what does a queue mean? So if you go to a cinema hall or if you go to a station, either it's bus stand or railway station, you go for the ticket, right?
Yeah.
And in for getting a ticket, you stand in the line, right?
Mm-hmm.
Where a lot of people are there in front of you, and after some time, a lot of people will come after you, right?
Yeah.
So that line is also called queue, right? In literal, in normal word, in normal English, that line is also called queue.
Mm-hmm.
So what is the behavior in that queue? What is the behavior?
The first, it's a first in, first out. Like the first person will.
Exactly. The guy who is sitting nearer to the counter
Mm-hmm.
will get the ticket first, right? And then other guy will come. And
Mm-hmm.
also it's one by one, right? It's not like five people will get the ticket at once, right? So like one person will get the ticket. He will step outside the line, then other guy will get his chance,
Mm-hmm.
and so on and so forth. Correct? So here also in our data structure, queue has its own literal meaning. It's a FIFO, it means first in, first out. The guy who has come first will be the one who will be served first.
Mm-hmm.
Okay? Or not? So stack, if you have Redis, and it has other properties also,
Mm-hmm.
like it gives you one element at first. Sorry. And similar to a stack, you cannot look in the middle. Even though you're using array for implementing your queue, you cannot check out what is at the middle. At any point, you can only get one element.
Okay.
And the stack has only one concept called top, right? But since queue, it has two things, right? If you think about a queue, how
Mm-hmm.
does a queue begin? So look, it's like a long line. Let me draw a picture here. That will be better for you. So in a queue, what will happen? So queue has basically two pointers. At one point, there is a guy who will be adding something into the queue, right? From the behind,
Mm-hmm.
right? We call it as behind as well as rear. The term is it has two terms. Generally, it's called rear, right? REAR.
Okay. Yeah.
Okay. And then there are some guys who have already been put into this queue
Mm-hmm.
and are sitting down, right?
Okay. Mm-hmm.
And the guy who was put first will be the one will be popped out from the queue first, right?
Mm-hmm.
So this area is called front.
Okay. Mm-hmm.
So stack has only one thing called top. You push at the top, you get from the top, and you pop from the top, right?
Mm-hmm.
But a queue has two pointers. One is called rear, where you push the data, and one is called front, where you get the data from. Okay?
Okay.
So since we are studying queue, I think you might be knowing why I started why I asked the question of two pointers from you. So because a two pointer is something which will be used in the queue also. Not in the same way we used, but in a different way. Okay,
Mm-hmm.
cool. So here, oh my god, this is I don't like this about this tool. I don't have option to go back to this area. But anyway, in queue, we push in the rear and get from
Front.
front, right?
Okay.
And also you delete from the front. You can't delete from the rear.
Mm-hmm.
Okay. Similarly, it has like it's similar to a stack. It also has three functionality.
Oh, so we cannot get the element from the rear, only from the
No,
front.
no, no.
Okay.
Exactly. Because it is possible that the guy who is sitting at the back of the queue will get the ticket from the counter.
Mm-hmm.
No, right?
Yeah.
So same thing is here. You can't get only you can only use rear for pushing something, and you can only use front for getting something.
Okay. Mm-hmm.
Similar to stack, it also has three operations. One is called push. One is called here. It's not called top. It's called get front, right? Or simply front.
Front. Okay.
Look, library there may be some other name, but these are like
Yeah.
you can
Okay.
say
Mm.
very broad level name, or you can say like very common name,
Pop.
and it is called remove.
Mm.
Pop or remove.
Okay.
In this we call it as remove. In
Mm-hmm.
language, there may be pop or get whatever it doesn't matter, right?
Mm-hmm.
But and look, a stack has only one variant, which we have just studied, right?
Yeah.
Queue has other variants. Uh, uh, Unlike a stack, queue are basically of majorly three types, right? One is that normal queue that we read, that we have just studied. Okay,
Mm-hmm.
why are we writing three? Other is called DQ. You know what DQ?
Yeah.
You know what DQ? It's called doubly ended queue.
Oh.
So what happens in double-ended queue is that you can use front and rear for both the operations. It means you can push from the front,
Mm-hmm.
you can get from the front, and you can push from the rear and get from the rear. Double-ended queue means both the ends are open.
Oh.
Did you get the point?
Like, is there any real-time example for TQ?
For example, I can give you one example like this. It's a real-time example. I don't recall any real-time implementation of queue itself. It
Ah.
will depend. It will depend on the problem. I can come up with some problem where you will be using double-ended queue. I remember one problem. Let me just think a bit. I think in yeah, I think when we use something like yeah. So I think if I'm not wrong, when we use 01 BFS in graph, I
Mm-hmm.
think we use double-ended queue. I don't exactly recall, but yeah. When you will, you know what 01 BFS in Do you know what 01 BFS or like multi-source BFS in this graph? Have you heard about this multi-source BFS?
No, actually.
No, but that's okay. So I think in case of multi-source BFS only, I think we use WQ. When we will come to that, I will give you. But if you talk about the example, I will give you some problems where you will have to use WQ. Okay.
Okay. Yeah.
But conceptually, just understand in WQ, you can use rear and front both for pushing the data and both for popping of the data. Okay.
Okay.
And then something called circular queue.
Mm-hmm.
Have you heard about circular queue?
I mean, the front and rear will like is it like circular linked list similar to?
No, 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 not like that. In this case, what happens is that
Mm-hmm.
in normal queue, you push from the rear and get from the front. In circular queue also, you follow the same principle. But what happens is that suppose you are using an array, right?
Mm-hmm.
And in the array, if you are getting from, suppose you start from the zero, you add in 1, 2, 3, 4, 5. So now rear is 5, front is 0, right?
Mm-hmm.
You got the point?
Yeah.
You had 5 elements, so rear is 5. Because if you will add next element, that will be added at the sixth position, correct?
Mm-hmm.
Or not?
Yeah.
So your rear is 5 and front is 0 because you have not popped anything out, right?
Okay. Mm-hmm.
And then you pop something. Then your front will become 1, right? Your front is 1, rear is 5, correct?
Oh, okay. Mm-hmm.
And now your zeroth position is empty, correct?
Mm-hmm. Yeah.
So in normal queue, your normal queue, your zero position will always remain empty. In circular queue, since we are moving front one by one,
Mm.
you are vacating the front of the queue, right? So not front of the queue, but front of the array that you are using, right?
Yeah.
Suppose you pop three elements. So now your front will come at the third position, correct? And
Okay.
position number 0, 1, 2 are free. Let me give you an example, right?
Like in normal queue also, when we are popping the element, the front will decrement.
Exactly.
Oh.
But in this case, that is a normal queue. You can't do anything that. That will be that at least if we are using an array to implement the queue,
Mm.
that position will be wasted. We can't do anything at all. But
Oh.
in circular queue, we can do something. How? Suppose you are creating a array of size, suppose size, how many size? 1, 2, 3, 4, 5, 6, right?
Mm.
Suppose you are having a array of size 6 for queue. Okay.
Mm.
Now we push 1. Initially, rear and front both are like 0, right?
Mm.
Now we push 1, 2, 3, 4, 5, 6. Correct?
Mm.
So now this is your rear. Now your rear is at this position
Mm.
and the front is here, right?
Yeah.
Now let's remove 1, remove 2. Now your front is here, correct? Now these two positions are vacant, correct?
Yeah.
Or not?
Yeah.
In normal queue, if
Mm.
I tell you to add 7, you can't add 7. Why? Because your rear is at the end of this array, correct?
Okay. Uh-huh.
You will say your queue is full. You can't add anything into the queue.
Mm.
Did you get the point?
Okay. In this case, we will be adding it in the front.
No, no. In normal queue, in this queue,
Mm.
even in WMX queue, for example, if you are told to add it at the rear, you
Mm.
can't add anything. You will say, okay, I don't have any space left at the end of the queue. I can't add anything at all.
Mm-hmm.
Okay. But in circular queue,
Mm.
since we know that these positions are vacant and
Mm.
our because our front is at this position,
Mm.
you can add this 7 here
Oh, okay. Mm-hmm.
in circular queue. But only so in circular queue, if your front is moving and your rear has entered, you can come back to the top of this array and put the element.
Yeah, got it. Like it's space efficient.
Exactly, a specific. Here you are wasting the space.
Mm-hmm. Yeah.
But see in circular queue, unlike normal queue, the number of conditions will be more complex. So you can say more conditions will be there, right?
Okay. Yeah. Mm.
Yeah. So I think we have some time left. So let me implement normal queue,
Mm.
and as a part of your work for your home, you can implement WQ and circular queue.
Oh.
Okay.
Yeah.
So, but before implementing, do you have any question from the theoretical aspect of the queue, whether it's queue, WQ, or circular queue? Anything?
Nothing. Like when I try to code, I think I'll get more questions on the condition.
Awesome, awesome. So let's start. Here also we will create size.
Mm.
We are using like array suppose, right?
Mm.
We are equal to -1. In the beginning, there is nothing. Real -1 meaning, what is the meaning of real -1? There is nothing.
Nothing.
Front -1, we want to push anything, right? It means Q is empty, right?
Mm.
Now we have to push, right?
Mm.
How will you push? So first of all, we will check for the boundary condition. And in case of push,
Mm.
what will be the boundary condition? Tell me.
Like if it's the queue is whether it's full or not.
How will you check whether it's full or not?
Um.
So look, in a queue, where do we put the data? We put at the rear,
Yeah. So rare.
correct?
Yeah.
If first of all do, we will implement rear,
Mm-hmm.
correct?
Mm.
And if
Rare
rear equal to
-1, then it's full.
correct,
Yeah.
and then element, right?
Mm.
It's very easy, right? There's nothing. difficult here, right?
How will we assign the front? Like if it's an empty,
Exactly. You tell me.
I mean, if the queue is empty, we have to increment the front.
You have to increment the front from S1 to 0.
Yeah, if queue is empty.
And if you're adding element, look,
Mm,
there are two ways. This can be a way, but there can be other way. If you want in this way, we can have in this way. We can say, okay, this can be a way, right? If the queue was empty, we will also increment. Other way is that while getting the top, you can increment the front, right?
okay.
So if you choose in this way, we can do like this. This is what we were looking for, right?
Yeah.
So if the queue was empty, we have added the first element, there will be 0.
Mm,
So make the front as 0.
mm,
Correct? And now if we say now let's implement remove element. So look, we always remove from the front.
mm.
What is the boundary condition?
If empty.
Exactly.
Mm, remove.
And then what do we do?
Uh, decrement.
Correct? Decrease the front by 1.
Mm. We will not
Tell
do
me.
for rare, right?
No, no, what is this correct?
Yeah, we'll decrement the.
No, the increment. No.
Oh, okay, okay. Uh-huh. Acha, got it.
Why do we decrement?
Yeah, we'll increment the
We
front.
are reading from bottom to top. You are reading from top to bottom, right?
Yeah. In case of rare, we will not do anything, right?
Yeah, and one more thing.
Mm.
Is there any other condition which we should check for in remove or are we good? Tell me.
Like if front is equal to rare, will there be anything, any condition?
It will just look that is not bad because in that means that may mean that this queue is only having one element, right?
Okay.
Or not?
Yeah. I mean, if front, what I'm thinking is like if front is equal to rare, then we'll have only one element.
Exactly, but that can be removed, no?
Uh,
But that can be removed, right?
yeah, if front is greater than rare, then
Exactly. So either front is bigger than rare
mm,
or front is equal to n. In that mean and that will mean that there is nothing in Q to remove.
okay.
So yes, that will be a condition. Then also fail. Are we good or
Yeah,
not?
yeah,
Okay. So here we have checked for all the boundary conditions. Let's implement the last method, which is tell me what are the boundary conditions? First boundary condition is simple, right? So look here you can say that the boundary conditions for remove and front are same, right?
mm,
We'll say okay. Nothing to.
Okay.
Otherwise, what?
Return front element, A of front.
Yes. If only you can implement to get size of those things, but it's up to you. It's not a very big deal. If you
Okay.
want to get the size, it will be like what? Rear minus front, right?
Mm.
Plus one, of course.
Yeah.
What is the size of the cube? Like rear minus front plus one.
Mm.
Correct?
Yeah.
Or not?
Yeah.
Cool. So with this, are we done with the queue or do you have any questions in the queue? And yeah, before
Mm.
coming to that,
Mm.
tell me the time complexity of all the operators.
Uh, I think for front it's O of 1,
Okay, it's correct. Was one.
and for pushing the element also it's O of 1.
Okay, and then
So
are
while
we moving?
we were just only incrementing the front, right? Okay, that is also
Yes,
O of 1. Okay.
that's all. So
Mm-hmm.
yeah, that's all. We are done here. So you can do one thing.
Mm-hmm.
I mean, since you already have one stack question to solve, right?
Mm.
Try to implement circular queue or WML queue if you have time.
Okay,
Try
okay.
to do these three things.
Mm-hmm.
Tomorrow we are meeting, right? Or not?
Yeah, we're
Tomorrow
meeting.
we are meeting.
Mm.
Okay. So since we are meeting tomorrow, I will come up with some. I mean, since I know a lot of I know some problems, so I will. mm, So what we can do is that we will try to solve similar to today, right? We solve one question on stack. Similarly, we will solve one question on queue.
Mm.
Okay,
Mm.
and then I will give you two or three problems on queue to do by yourself. And
Okay.
tomorrow,
Mm.
what do you do? You want to study map and set, and then move to tree?
Mm.
And I mean, how do you want to do this? You want to start? You want to study map and set, map and set?
Yeah, I want to do those things also. But in the week, I will
And if you know,
focus on these concepts.
sorry,
Like during the week, I'll do more problems on these concepts.
yeah, it's up to you. I mean, I would, I will be very happy if you will do practice in these topics.
Mm. Okay, yeah.
Cool then, let's meet tomorrow. Anything else that you want to add? Or should we end the call?
Yeah, that's pretty much. We'll see tomorrow.
Okay. I mean, once the recording is done, can you please send me the complete recording?
Okay, okay, sure.
You
I'll.
can just upload it into the drive and share it with me, or however you want to do. You can do it.
Okay, okay.
Uh,
Mm-hmm.
just write my. Sorry, you can just. I will pin you my email ID
I'll mail to
on
that.
WhatsApp.
Okay, sure.
Yeah.
Again?
So the question goes like this.
Mm-hmm.
I think a lot of companies have asked this question also. Implement a queue using a stack. And this very objective question that is asked that
Uh-huh.
how many stacks are required to implement a queue? How many stacks are required to implement a queue? Just think about it and let me know. Yeah. How many stacks are required to implement a queue? Tell me.
Maybe 2 stacks.
Yeah, that's the correct question. How will you implement? Uh, Don't think about that complexity, just tell me how will you implement. That may be a bit costlier as,
Mm-hmm.
as compared to the normal implementation, but the question is how will you implement? Hello?
So, like, how are we giving the input?
No, it's not about giving input. It's just about Implementing. It means, look, when we say about implementing data structure, what does it mean? It means that you have to implement all these functionality. And
Mhm.
what functionality does Q have? It
Okay.
has three basic functions, right? Push, remove, and get right.
Okay. Okay. Functionalities.
And all things like get tag, these are like very minor things, but these are the major three functionality of Q, right?
Mhm.
You push something, you get the front, and you remove something. So when anyone tells you, if someone tells you implement a stack, what does that mean? You have to implement the three basic functionalities of a stack, which
Oh,
is push, pop, and top.
yeah, we can create two stacks.
Okay.
Like for, I mean, this is my guess. So, like for doing the push function, so whenever we are pushing, we can directly push into one stack, and
Cool.
whenever
That's
we
correct.
are eliminating an element, we can eliminate that into another stack, the stack two or another stack.
Yes, you can dump everything into the other stack, and you can get the top of the stack, right?
Yeah.
Yeah, that's correct. That's why we need to. When you have to push into your stack. When you have to get the top, how do you want to do that? You can put everything back into another stack
Okay.
to
Mhm.
get the top from the stack, and then put everything back into the first stack, right?
Yeah.
And same goes for removing something. You have to remove the first element of the queue, pop everything from the current stack, put into the other stack, remove the topmost element, and
Mhm.
put everything back into the first stack,
Yeah.
right?
Yeah.
Or not?
Yeah. That's right.
Awesome. Yeah, this is a very like it is a very classical problem in queue.
Okay.
So you can write a code for that also. Implement the queue you're using to a stack, and I think a lot of companies ask this question. I remember many companies have asked this question. You can just Google, and I think if you have Googled already, then you will find that okay, a lot of companies have actually asked this question.
So like we have to do only the queue functionalities. We don't need to bother about the front and rear.
No, no, you don't care.
Mm.
Look, when you call the get front method of the library
Mhm.
that is implementing the queue, you
Mm.
don't know no, that how what is real, what is front for them. You just get whatever you desire, right?
Yeah.
So someone is calling a function. They don't care how this has been implemented,
Mm-mm. Okay. Mm.
right? Or not?
Yeah.
Okay. There's one more question that you can solve, and the question goes like this. Hmm. So I think this question is I'm not sure how much people ask, but I always find this question
Mm.
good as far as implementation of queue is concerned, right? So you are given n this, right?
Mm.
Okay, for n days. Okay, for n days you are given n days. Correct? You have to build a tower. Okay, or not?
Okay. Yeah.
Now the condition is that
Mm.
you cannot add any disk in the tower if you know that in disk of bigger size will be provided in future date. Look, if you're taking a tower from the disk, how will the tower be created? Largest at the top and smallest at the largest at the bottom and smallest at the top. Correct?
Okay. You cannot add
You are
any.
with me, right? Or you just lost me?
Means that. Can you give me an example? Cannot add any.
I can give you an example, but first of all, let's think about tower. Tower is like a building. So how does a building look like? Tell me. Look, normally the building, how does a building or tower look like? At the bottom, it is bigger, and at the top, it is smaller, right?
Okay. Acha. Uh-huh.
Not
Yeah. It should be like in the ascending order.
exactly. I will show you one example. Let me just show you using this example. So, look, your tower should look like this, like say,
Mm-hmm.
correct, right?
Okay.
This is how a tower. This is how a tower looks like, correct or not?
Yeah.
Now, these are the individual discs, correct?
Okay.
So, this is how a disc would look like,
Mm-hmm.
correct or not?
Mm.
Okay. So this is what it means. If you know that, if you know, and how do you know? Because you are already given the estimate of all that discs and how this test will be provided to you.
Mm. Mm.
Correct?
Mm. Yeah.
You have to return all the discs that will be added to tower on each day. If cannot be if we cannot add any disk on a single day, then return empty for that day. Correct?
Okay.
Let's
Mm-hmm.
see it through an example. So you are given the disk for 5 days. The disks are like 4, 5, 1, 2, 3. Okay?
Mm-hmm.
So look, we know that if we have 4 and 5 is coming, look, what does it mean? It means that on the first day you will be given disk of size 4, on second day you will be given disk of size 5, third day disk of size 1, fourth day disk of size 2, and fifth day disk of size
True.
3. Correct or not?
Yeah.
Okay. So now we know for sure that on the first day we are given disk of size 4, but on second day we are going to get a disk of bigger size.
Why? Yeah.
So on the first day we don't add anything, correct?
Mm-hmm.
On second day we get 5, it means we will add 5, and we have 4, and we know that no bigger number is coming after 4. We can also add 4 on the second day, correct?
Oh, on the first day we are getting 4, right? So we are not adding that.
No, because we know now, look, these are the estimates that you are given all these on the first day, right? That which
Oh,
size ka disk will be given on which day.
oh, we have to organize it. Okay.
Yes. So on
Mhm.
the first day we add 6 to 5. So on first day we don't add anything at all, right?
Yeah.
On second day we add 4 and 5. On third day we have 1, we can't add 1,
Mm.
right?
Yeah.
On second day, sorry, on fifth day we have 2, but we know that 3 is going to come, so we don't add 2 also, right? So fourth day is also empty. But on fifth day we add all the 3, right?
2, 1. Okay. Mhm.
That's our answer. First day nothing, second day 5 4, third day nothing, fourth day nothing, and fifth day 3
Yeah.
2 1.
Okay.
Correct
Yeah.
or
Mm-hmm.
not?
Yeah.
Now you tell me how are you going to solve this problem?
I think we can use stacks.
Yeah, I mean it's up to you whatever you want to use.
Like for if there is we are not using any disk on a particular day, we have to return either 0 or -1, something like that.
Sorry?
If we are not using on any disk on a particular day, so we have to return 0.
No, it's a error, na, so you return empty error, not 0.
Oh, okay. we can use the stacks, so we can append accordingly. Like if our previous element is greater than our like our previous element is less than our current element, we can pop it out and we can append the current element.
Yeah, but it's not only about creation first. No? What
Oh,
if something bigger is going to come in the future, right?
yeah, we have to add accordingly with the dates also. Okay. If we like, if we can create two stacks or one stack. So like if our like previous element is greater, I mean less than our current element, we can add an empty string to the array.
So you can empty list array. Okay.
Uh, and and whenever like our previous element is less than I mean greater than our current element, we can add those our previous and current elements, like for example 3, 2 and 1, like the 5, 4, 5 and 4, we can add that directly to the array, right?
Yes, but the question is how will you figure out that when to start adding and when to stop adding and when to actually stop?
Okay.
Tell me.
Mm. So like when to start means we are asking like with respect to the length of the array.
No, I'm asking about the ordering of the values in the array. When are you going to start adding and when will you stop it? For example, in on second day we have added 5 and we have also chosen to add 4.
Mm.
If there was like something called 1 rather than 4, we would not have added 1, right? Because we know that 3 is going to come after that. So we have to think when to stop, right? We have to take a decision of when to stop. Correct?
Okay, okay. Mm-hmm.
Okay, yeah, I absolutely wanted only.
So whenever like our previous one is less than our current one, we can stop that, right?
Previous one is less than current one, we can
Or
stop.
less than 5.
Yes.
So on day one, we can give an empty array or we can stop that.
Okay, that's correct on first day because we know that 5 is coming after that, right?
Mm.
Go on.
Okay, and again on. And again we can pop like so we are adding the 4 and 5 to our stack, right? So and we can pop those elements and add to the day 2, right?
Yes, that's correct. I totally agree with you. But the question is, when
And
you are adding 4, how will
mm,
you justify not to put it in the result? And when you are adding 5,
mhm.
how are you taking a decision? Okay, this is the best time to stop adding and start pulling them in the result section. and not wait for the other elements to come. Did you get my point or not?
Sorry.
Did you get my point or
Yeah,
not?
yeah, I got it.
Okay.
Like until the
You
stack
want to try it at your home?
until
Your
the
home?
stack is empty, we can add right.
If you're adding into a stack, how can a stack is empty?
Um, I'm not able to figure that particular point.
Okay. No, so that's okay. So we can do one thing. If you want to give me solution, I can give you, but I would say that let's try it once. So try it at your home and
Okay.
then let's try to solve it and let's try to see it later. Okay.
Yeah, I'll try once. Yeah, sure.
Okay. So today we will start our new topic, which is like maps and sets, right?
Mm-hmm. Okay.
I think you might be familiar with them since you always talk about dictionary. You might be aware of the fact that there is something called maps. So whatever dictionary you use in your Python is nothing but map only, right?
Yeah.
But let's look at the theoretical aspect of that.
Mm-hmm.
What is a map? Okay. So look, first of all,